For decades, scientists have sought to understand how these subtle changes in the sun's power might be affecting the Earth. It's a puzzle that led one man to look away from the sun and focus instead on the rivers around the Iguazu Falls. Argentinian astrophysicist Pablo Mauas.
It's a very large river. It's the fourth river in the world. Unlike other larger rivers than the Paraná, for example, the Amazon or Congo, we have data of this river for the whole 20th century.
Oh, so you can look back to, what, about 1900? Or...
Yes, from 1900, 1904. And this is because this is a river that can be navigated by very large ships.
Pablo brought the statistical tools of a physicist to bear on 100 years' worth of precious river records. What emerged was that the river, too, had a rhythm.
We found that the stream flow of the river goes up and up again and down again 3 times during the century. And we went further trying to understand why.
The amount of water in the Paraná River seems to be following a pattern. The question is, what could be driving the change in these vast river systems? Pablo first looked to the 11-year sunspot cycle, but found no fit. So instead, he turned to calculations that describe the sun's underlying brightness during the last century. He showed me what happens when you superimpose this solar data on the water levels in the river.
You see that when the sun goes up, the river goes up.
So what this is saying is around 1925 or so, that there was more solar activity. So the amount of, really, the solar radiation falling on the Earth.
Right, there was relatively more activity, solar activity, in these 3 periods we can see here.
I mean, it's a beautiful correlation between the water flow, the flow in these rivers, and the solar output.
Yes, it is. We find it's a very striking correlation.
Changes in the sun seem to move weather systems elsewhere too. In India, the monsoon appears to follow a similar pattern to the Paraná River, whereas in the Sahara, the opposite seems to occur: more solar activity, less rain. The exact mechanisms by which our star may affect Earth's weather remain, for now, a mystery. We know that the energy production rate of the sun, the power released in the fusion reactions at the core, is very constant indeed. It doesn't change as far as we can tell. And so the changes that we see must be to do with the way that energy gets out of the sun. And whilst it's only at the 0.1% level in the amount of radiation that falls onto the surface of the Earth, it really does reveal the intimacy and delicacy of the connection between the sun and the Earth.